Dear students, Assalamu alaikum. Today our lecture is about waste reduction. In our previous two lectures, we talked about water pollution reduction, then we talked about air pollution reduction. Now we will be focusing on solid waste reduction. Now again our focus will be on the adoption of cleaner production technology in order to reduce the waste. And again our strategy will be similar to the previous cases. The approach which we adopted for water pollution reduction and we adopted for air pollution reduction, again the same mechanism and strategy will be adopted for the waste reduction. We will be talking basically about the definitions like waste concept and so anything useless resulting from a process or activity will be declared as waste. Um, there is initially when there was not so much amount of unwanted material around. In that case, our every waste which can be called a waste was not actually a waste but a resource. We tried our best to reuse that waste. So in our early days and even now you can see that our most of the waste produced from one activity or the other activity is normally capable of being utilized as a resource. It can be reused, it can be recycled, or it can be molded, it can be transformed into another form to make it usable. So there are different options available. So what we do, we try our best to reuse our waste. So waste which is actually unwanted unwanted thing or material from one process is not necessarily waste for another process as well. For that process, it can be used as a raw material, as an input material. So, therefore, we can say that waste is an unwanted material from one process, but it can be reused in another process. So that's what we do, and normally we try our best to maximum utilize our resources which are available to us, and again those resources will be utilized in different forms and shapes and for different processes. It is also possible that there is a closed loop and waste produced from one process is reused in the same process again, but there is another option of one loop, open loop, in which the waste produced can be used in some other process or in other shape or in other form. So we will talk about it later on, but now we are just talking about the basics, what actually waste is. So waste is unwanted material from one process. Okay. Pollution may be seen as a form of waste because pollution is also an unwanted material, unwanted or toxic material produced as a result of some activity or some process, and waste is following the same pattern. So there is no difference in pollution and waste. And then both are going to threaten our environment in one way or the other, and both are going to disturb our ecosystems, and it is going to disturb our balance, our cycles. Most of the strategies and technologies discussed earlier can be used for solid waste as well. So It is a sign of inefficiencies in the production process or shortcomings of the product which has to be wasted. So by improving our efficiency or our process, we can achieve the maximum utilization of the product. But in most of the cases, we have some byproducts which are also not required. So we are also going to call them as waste. How to produce less waste? This is a very important thing. So again, by improving the efficiency, it can be reduced, and being more careful, and we will be able to use our input resources, and this leads to cleaner production approach in which we are more sustainable about our resources. However, a production process which only produces products is seldom a realistic goal. Some waste will always result. This is what we talked earlier. Now, normally in our processes, we are supposed to get byproducts which are not wanted. We are only looking forward to products, but these byproducts are not used or not required. So these are called waste. So waste is something called as a useful resource but in a wrong place. So what to do with waste to turn it into a resource? Just look at the example. When the SOx, sulfur oxides, extracted from a flue gas stream in a wet scrubber is transformed into gypsum. This is used for the production of gypsum boards or for construction industry. So sulfur oxides, which are a settled product, a particulate matter in the form of particulate matter, it is going to settle down in our wet scrubbers and in our stakes, industrial stakes or incineration unit stakes. Then it is going to settle down. We are going to separate it, these sulfur oxide compounds, and then we can transform it into gypsum, and these gypsum boards will be used for the construction purpose. Then we have some formal definitions of waste according to European Union directive, as well as the International Basel Convention on Control of Transboundary Movements of Hazardous Wastes from 1989. Waste is defined as substances or objects which are disposed of or are intended to be disposed of or are required to be disposed of by the provisions of national law. Then the Council Directive defines as waste shall mean any substance or object in a waste category which the holder discards or intends or is required to discard. Discard means to dispose of. So we are no more requiring that compound or component anymore. These are the categories of waste according to EU directive, European Union directive. You can see that Q1 defines the category production or consumption residue not otherwise specified below. Then we have off specification products which don't have any specification, products which date for appropriate use has expired, materials spilled, lost, or have undergone other mishap, and then materials contaminated or soiled as a result of planned actions, unusable parts like batteries. Now this part on this category onwards up to Q11, it will deal with the industrial waste, so please check it out. So Q7 is substance which no longer perform satisfactory perform actions. residue of industrial process, residue from pollution abatement process, matching finishing residue, residue from raw material. These are industrial waste categories. Then we have some other remaining categories you can go through. Now, industrial solid waste and the categories we earlier defined from Q6 to Q11 are going to be covered under this heading of industrial solid waste. The amount of waste as a percentage of production of the resource extracted is very different from the different mining processes and sources. Thus, for example, copper mining gives rise to a very large amount of slag or overburden, typically more than 99% of the total, while in iron mining it is less. This waste is often landfilled at the site of extraction. Then sometimes this is rather harmless, as in the case of most iron mining waste, and then in other cases it is a serious threat. Thus oil shale mining has created mounds of waste which leaks thousands of tons of wastewater, and which is going to be treated as toxic wastewater. Then the residue from pollution abatement processes also going to be industrial waste, solid waste, like coming from scrubbers or from other incineration units, flue gases, and the units dealing with the flue gases. Then what are the waste management strategies? So, waste hierarchy, waste minimization or source reduction, cycling, waste treatment, landfill. Waste hierarchy means in which pattern we are going to deal with our waste. Well, let's see what it is. The waste hierarchy classifies waste management strategies according to their desirability. The term 3Rs, or reduce, reuse, recycle, has also been used for the same purpose. The waste hierarchy has taken many forms over the past decade, but basic concept has remained the cornerstone of most waste minimization strategies. The aim of the waste hierarchy is to extract the maximum practical benefits from the products and to generate the minimum amount of waste. Some waste management experts have incorporated a fourth R, that is rethink, which implies that present system may have fundamental flaws and that a thoroughly effective system of waste management may need an entirely new way of looking at waste. So, according to sixth European Union Environmental Action Programme, the EU approach to waste management is to prioritize waste prevention, and it includes recycling, waste recovery, incineration, finally, last resort about landfilling. The target is to reduce the quantity of waste going to final disposal by around 20% of the uh, 200 2000 level, year 2000 level by 20, year 2010, and in order of 50% by year 2050. So, the waste hierarchy can be used most effectively as a guide to ensure that when developing a waste management policy or decision, an integrated approach is taken where all options are considered. Now, another important thing, that is the waste minimization at the source. Obviously, when you study solid waste management, the most appropriate approach is to reduce the solid waste at source. There are so many options which can be adopted, like it will help first of all to reduce hazardous waste and other waste materials by modifying industrial production. So our focus is to let the waste be produced in the minimum amount. We don't want to produce more waste. So adopt those techniques in which we will be able to reduce our waste. It can be done by improving the process. It can be done by changing the requirements. We should be using lesser input material, and then that material will be efficiently used. Then source reduction method involves change in manufacturing technology. As a consequence, source reduction falls well within the concept of cleaner production and pollution prevention. A practice that is being adopted in several countries, either as voluntary measures or as a legislation, is the extended producer responsibility (EPR) of holding uh, the producer of a product responsible to some extent for the management of the waste products associated with that product. Now, what kind of this thing can be? For example, our TV sets, for example, our refrigerators, for example, our monitors, our CPUs, our other electronics appliances, all have some specific chemical being used within that unit or appliance. Now, if the consumer, the buyer, buys that unit and it utilizes it for a specific time interval, and then he wants to dispose it off, at that moment the seller, the person who sold that product is also responsible for managing this proper disposal. Now, the manufacturer or seller is equally responsible to dispose of this product which has completed its life, or the seller or consumer has already finished the usage of that product. So by doing this, the manufacturer is going to share the load, because he is the person who is uh, uh, shifting the waste from one place to the other, and he is going to take the responsibility to deal with it. And then he can also have some research work to reduce the waste, and use those products which are less harmful in that appliance. By doing this, and in most of the cases, if you see new products nowadays, new appliances like refrigerators, modern equipments, monitors, you can see at the back of that there is a slip, there is a message that if you how to dispose that product. And again, the manufacturer is having a share to properly dispose that product. Then we have a recycling concept. It's very common. Returnable beverages, glass and PET bottles, which can be recycled. We can reuse these materials as it is. And then there is a secondary recycling, where the waste is used to replace virgin raw material, input raw material. So the end product is being reused as a input material. So out product outcome is equal to the input material. Then we have a closed loop or an open loop. This we talked earlier. In closed loop system, recovered material and product are suitable substitutes for new materials. Therefore, theoretically, a closed loop model can operate for an extended period of time without new material. Now what actually is going to happen, that the end product is capable enough to be reused as a raw material, as an input material, as a new material. So this is called a closed loop. So solvents and other industrial processes are the most common material recycled in the closed loop. And especially if you consider the example of tannery waste, there is a chromium salt being disposed of as it is, which has completed its product process is its sorry its function as a catalyst. Now it is being disposed of. Now if we recover that chromium in its original form, we will be reusing that chromium as a input material, as a raw material. We don't need to use new and extra raw material. So this will help in the reduction in the material consumption. Overall reduction in the consumption material is the basic principle of cleaner production technique. Now open loop recycling occurs when the recovered material is recycled for one or more times before its disposal, and then there are some examples. You can go through these examples on your own. Now the popular meaning of recycling has primarily come from to refer the widespread collection of reuse of single-use beverage containers made of aluminium, glass, HDPE, PET. HDPE is high density polyethylene. Then these types of containers may also be collected and sorted into common groups, and so that the raw material of the item can be recovered and used for production of new containers. So please go through the example. Then recycling of the material or molecular scale, also called tertiary recycling, is more seldom applied principle, but in principle a possible way of utilizing waste. Then one example that is has been investigated is polymer recycling by process polymers into original monomers or other simple molecular compounds and then building new polymer molecules. One material that may be recycled in this way is polyethylene terephthalate. Although it is still not economically feasible. Then resource utilization or downgraded recycling. How to do this? We will be getting raw material from one process, it will be reused in some other process. Instead of reusing the product or the waste material in a recycling material flow, material is used for applications with less requirements regarding the purity and quality. Now this is called downgraded recycling. An example of this is the use of recovered PET material for production of insulation material or for production of fleece fabric. Another example is the use of crushed glass as a light material, lightweight filling in the road construction. In principle, also composting could be classed as downgraded recycling. By composting, organic material is converted into compost, humus, or soil that may be used for soil amendment and to replace commercial fertilizers in gardening and agriculture. Energy recovery from waste. is very common. Household waste as well as industrial waste consist to a large degree of combustible material as paper, wood and other organic materials. This can be incinerated with energy recovery for heating and power production purposes. Now waste treatment. Waste treatment actually means to modify the waste, to make it simplified, to make it lesser toxic, to decrease its toxicity level, and to transform it. Basically, this is a processing of the waste into another form which can be reused or it can be recycled, and transforming its original characteristics into some other characteristics which are again required for another process, and to convert waste to substance that either be introduced into natural material cycles or to be safely landfill for disposal. So please go through this, and then there are some treatment methods like thermal treatment, which can be done by incineration, gasification and pyrolysis. Biological can be done by composting and indigestion. Chemical by oxidation, reduction and precipitation. So please go through it. And then landfilling, the last stage is the waste in the waste management hierarchy is to deposit the waste on a landfill. This alternative is the last resort and should, as expressed in most environmental policies and targets on the international, national, local levels in communities and enterprises, be phased out or reduced as much as possible. Now, reducing waste through cleaner production methods. Actually, we have already done most of the things through the cleaner production approach. Like source reduction is a cleaner production approach. So, mining waste. How to deal with mining waste in such a manner that a cleaner production approach is used. So again, it should be reused in a sustainable manner. It can be reused for road construction process, and then alternative ways of extraction of metals may produce less waste. An example is copper mining using biotechnological methods called bioleaching. In this approach, microorganisms are used to extract metals from sulfidic ores by treating the water passing through a mining field. Bioleaching is a commercially used to process ores of copper, nickel, cobalt, zinc, and uranium. In the process, microorganisms catalyze the oxidation of iron sulfides to create ferric sulfate and sulfuric acid. So please go through it on your own. These are just examples. So biooxidation is another process linked with it. Recycling polluted residue. Now the waste once been disposed along with the main wastewater stream, let it be recycled, let it be extracted from the wastewater. Just as the example we took for chromium from coming from the tannery waste, this can be recycled and then we can reuse it as a raw material, as an input material. A typical cleaner production strategy is to take care of polluted material to make it useful. Thus, contaminated solvents may be recovered by membrane separation and redistilled to be used over again, a common practice in pharmaceuticals production. Efficient use of materials. A process designed to use material in the most efficient manner reduces both material input and materials such as textile, paper, or metal sheets used for cutting out pieces may be used more efficiently if the cutting process is optimized and carefully planned. Then we have resource conservation, in which a less material intensive product may also be having a lighter weight, thus saving energy in distribution or use. So let's produce a material which is lighter in weight so that we use lesser raw material. So we are actually conserving our resources. Our raw material is saved, our energy is saved, so input material is saved. Then what future developments are in process? Again, the same as you studied earlier, the Basel Convention was principally devoted to settling up a framework for controlling the transboundary movements of hazardous wastes. Then in 1999, the convention was revised and refocused, and then its focus was on the efforts to minimize hazardous waste generation, active promotion and use of cleaner technologies, and reduction of the movement of hazardous and other waste, the prevention and monitoring of illegal traffic, improvement of institutional and technical capabilities for the developing countries, and future development of regional and sub-regional centers for training and technology transfer. This means that the international priorities in waste management will be turned towards issues very central to cleaner production. So that's all for today's lecture, in which we talked about waste reduction. And almost the same cleaner production strategies were adopted as we adopted in our previous lectures, which were focusing on the air pollution reduction and water pollution reduction. So please go through this chapter. This is chapter number 10 of the book which I have recommended to you earlier. So it's quite simple topic, and I wish you to go through it thoroughly and apply this in the industry. Thank you very much for your time.